Hello students, welcome back to the class. Today we will see the NCERT exemplar of some basic concepts of chemistry. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the same. In this class, our objective would be practice and see the questions of NCERT exemplar. Okay, we will try to solve each important problem of it. So the question which I will be focusing on are 1.10, 1.6, 1.9, 19, 1.22, 28, 30, 36, 41 and 43. So these are all the questions that we will see today. So our first question is 1.10. Question is, the empirical formula and the molecular mass of compound are CH2O and 180 gram. So this is the empirical formula and this is the molecular mass. We have to calculate the molecular formula of the given compound. So these are the four options that are being given. How we'll solve this question? So it's very easy. You just have to calculate the n factor and do the corresponding thing. To do that, we first have to know the empirical formula mass. How we'll calculate the empirical formula mass? It will be calculated using the empirical formula. So just take the atomic weight of each of this. So it will be 12 into 2, 12 plus 2 into 1 plus 16 is equals to 30. Okay. So whoever knows the solution, they can just do this thing, calculate this before me and comment their correct answer in the chat box. Then what is the molecular mass? It will be 180, right? It is given in the question. We know the formula mass, we know the molecular mass. What is the formula for calculating the n factor? Sorry, n here, using the empirical formula mass and the molecular mass. Anyone who knows the answer to this formula? How do we calculate the n value? What do we take? Anyone? Yeah, it's true. Naman is saying 180 by 30. Yes, you are right, Naman. We take the ratio of the empirical formula. Sorry, we take the ratio of the molecular mass to the empirical formula mass. Yes, Shriram, you are correct. So let us do this thing. 180 by 30. That will give you 6 as the n value. Now multiply this 6 throughout the coefficient of each and every atom. So C, that is your carbon, has a coefficient of 1. So 1 multiplied by 6 will give you C6. Then for hydrogen it is 2. So 2 multiplied by 6 it will be 12. And for oxygen it will be 6 multiplied by 1, which is 6. So this is your molecular formula. So we can say that the correct answer is C6H12O6. Moving on. So these are the incorrect options. You can see it is not possible. So this is itself your formula mass, empirical formula mass. Moving on to the next question. So this is a question related to the mole concept. Again, I am suggesting you, if you are calculating the answer, you can just comment it in the chat section. The question is saying that what is the correct answer if we take 1 mole of oxygen? So it is a multiple select type question. First of all, there is not a single answer associated to it. There can be multiple answers. Okay. So just try to give both of this. Now, if I am saying that we have 1 mole of oxygen gas, that means we have 1 mole of O2. Okay, again, if I am saying that we have 1 mole of oxygen gas, then we have 1 mole of O2. Here oxygen gas means O2, because oxygen gas means we are taking the actual oxygen gas, and actual oxygen gas never exists as single oxygen entity. It will always exist as a molecule. Clear? So if we are taking 1 mole of oxygen gas, that means we are taking 6.022 into 10 to the power 23 molecules of oxygen. So A and D is the most voted answer. Let's see what is the correct answer. So first answer is obvious. So let us consider for the other one. So if we look for the other parts, then we can say that 32 gram of oxygen is also a good option. Why? Because 1 mole of O2 will be having a mass of 32 grams. Is it correct? Is it correct to say that? Yes, because the molar mass definition is itself says that the mass of 1 mole of anything. So the 1 mole of O2 gas will have a molar mass of 32 gram, as there are 2 atoms of oxygen present in 1 molecule. So 2 atoms in, say, two atoms in 1 molecule are present in the case of oxygen. Clear? Therefore, in 1 mole, 2 into Na number of molecules will be present. Correct? But here we are taking only 1 mole of the molecule. That means it will be 32 gram. 16 plus 16, it will be 32 gram. Hence, we can say that 1 mole of oxygen contains, first of all, the molecular weight of oxygen as well as the Avogadro number. Therefore, the correct options are A and D respectively. So, again, I am re-explaining this question. When I say 1 mole of anything, it means Na number of that same thing. Got it? So, when I am saying 1 mole of oxygen gas, and oxygen gas is what? It is O2. So, by this we can say that we have 6.022 into 10 to the power 23 molecules of oxygen. Now, why not atoms? Because when we are saying atoms, we only consider this O and not the O2. What about the second thing? So, for the second thing, you must know the concept of molar mass. If you want to calculate the molar mass, the formula is the addition of the atomic weight, okay, with a gram as the unit. So, in 1 mole of O2, we have this thing, which is 6.022 into 10 to the power 23 molecules of oxygen, and its mass will be 32, because 1 oxygen atomic weight is 16, okay, and 16 plus 16 will give you 32. I hope you are getting, you are now able to understand this. So, okay, let me explain it once more. So, when I am saying that I have 1 mole of O2, I have already given the definition that molar mass is simply the mass of 1 mole. So, this was told in the earlier class. Okay, this was told in the earlier class. Am I saying it right? Was it explained earlier, Nisarg? The definition? Yeah. So this was the definition. Now, here we have to do the same thing. We have to calculate the mass of this O2, and it will again be the molar mass. Now, how do we calculate the molar mass? How do we calculate the molar mass of anything? We take the coefficient, which is 2 in this case for oxygen, and multiply it with the atomic weight, which is 16.00 grams for oxygen. So that will give you 32 grams. Is it clear now? Okay. Now what about the other two options? Now let us consider why they are incorrect. The remaining B and C, why are they incorrect? So B is incorrect Because if we are saying 6.022 into 10 to the power 3 atoms of oxygen, then it means that we have 1 mole of oxygen atom. Okay, we have 1 mole of oxygen atom and not the oxygen gas. Correct. So this is not right for the reason. Now what about the second option? Yes, Akesh, you are saying right. Now what about the second option? Sorry, third option. So this 16 gram corresponds to 1 oxygen atom. Again the same thing. Okay. So this is the mass of 1 mole of oxygen atom, or you can also say it is the mass of half mole of oxygen molecule, because in half mole of oxygen molecule we will have 1 mole of oxygen, because 1 half means 1 by 2. Okay, so for that reason we can say that this is also incorrect. So these two things are related to atoms and not the molecules. Now moving on to the next question. Do anyone has any issue related to this? Is it correct? Yes, Nisar? Yes, so 1 mole of, okay, so please can you stop this chat which is going in the side section, because I can't deal with the doubts. Okay. So this is MSQ question. Yes. So 16 gram of oxygen means 1 mole of oxygen atom. Yeah. Yes, yes, Pratik, it will be 32. Yes, I will summarize it quickly once again. So when I'm saying that we have 1 mole of oxygen gas, it means two things are certain. First is 1 mole of oxygen gas means 1 mole of O2 molecules. And in 1 mole, we have 6.022 into 10 to the power 23 molecules. And what will be the mass of this 1 mole of oxygen gas? It will be molar mass. So molar mass will be simply 32 gram for O2, because atomic weight of O2 is, sorry, oxygen is 16. So 16 plus 16 for 2 O's will give you 32. Okay, so this was about this question. Now let us move to the next one. So I'm trying my best to make you understand this concept. So if you have any other chats, just do it somewhere else. Okay. Our next question is, which of the following solution will have the same concentration? Okay, you have to calculate the concentration. Now the question arises, which concentration can you calculate? Because it is not given here that which concentration is to be considered. The very obvious answer looking at this question would be, it should be your molarity. Why? Because we don't have the mass of the solvent given in any of these options. So for that reason, we don't have to worry about any other concentration other than molality. Is it clear? So again I am repeating it, since we don't have any other information like your density or your mass, the only concentration term that we can consider is molarity. Because for molarity we need two things. First is mole and second thing is volume. So in each of this, we either have the mass from which you can calculate the moles, or we have the moles directly given. For that reason, we will consider this. Okay, again it is a MSQ question. So so there is difference in the formula itself, right? So when we say that, okay, molarity is given, the molarity formula is number of moles of the solute or the component divided by the total volume of the solution. For the molality, which is L thing, it is total number of moles of the solute divided by the mass of the solvent in kg. Now let us move to the solution. How we will calculate? So we will calculate the molarity for each of this. For the first case, we will calculate the molarity. It will be number of moles of the sodium hydroxide divided by the volume of the solution in liter. So number of moles is calculated here. which is weight of sodium hydroxide by molecular weight of sodium hydroxide. So here it will be molar weight, not the molecular weight. It will be molar mass. Okay. So molar mass of NaOH divided by weight of NaOH divided by the molar mass. Okay. Now next thing what we have to do, just put these values here. It will be 20 by 40 multiplied by 1000 by 200. Now why I have multiplied this 200, divide this thing with 1000, because we have to consider the volume in liters. It will give you 2.5 molar. Till this point, anyone has any issue? With this calculation? So if you are able to understand this, you will get the whole question very easily, because we have to do each thing, same thing each time. So again I am repeating it. You have to calculate the molarity, as molarity needs the number of moles and the volume of the solution. So number of moles of NaOH can be calculated by using given weight by molar mass. So given weight is 20 and molar mass of NaOH is 40. So it's very simple to calculate. It is 23 plus 16 plus 1. Just add all of this, you will get the molar mass of NaOH. Got it? Now put these values here. Volume value is given as 200 ml. So if you look at the definition of the molarity, it says that number of moles in per liter of the solution. So we have to convert this milliliter into liter. Yes, so molarity volume is given, so molarity is the only option that we can go for. So if you do this calculation, it is 2.5 m. Got it? Now moving on to the second calculation. Again 0.5. So we don't need to calculate the mole in the second option, as mole is already given. So 0.5. But we need to convert this milliliter into liter. Therefore we are multiplying it by 1000, or you can say we are dividing this 200 by 1000. This will give you again 2.5 m. So one thing is sure, that A and B have the same concentration. Now we will move to C and D. So if you look for C and D, what will happen? They will be the incorrect one. Why? For that we have to look upon the calculation. So how we can calculate this thing? First is molarity of the C case. So the given mass is 40 gram. Well and good. Okay. And what is the molar mass of sodium hydroxide? It will be 40. So this will be 40. So this thing will be 40 here. Okay, just correct it. This will be 40. Molar mass of NaOH is 40. Then perform this calculation, you will get 10 molar as the concentration. Is it clear? Is this part clear? Now what about the fourth one? So if you calculate the fourth one, it will be 20 by 56. So we have taken 56 as the molar mass of KOH, because it will be 16 plus 1. Then this thing is, I guess, 39. So 9, 6, 15. 1, 16, 1 carry, 3, 2, 5. Yeah. So it is 39 for potassium. So it is 39 for potassium. So if you just add this all, you will get it as 56. 20 by 56 divided by the volume 200 by 1000, that will give you 1.785. Again, this value is not near to any of the other values. So we can clearly say that A and B have the same concentration. Yeah, NEET has only MCQ questions till now. But still, if you want to achieve something bigger, you have to be clear about your ideas, right? So if you're able to solve MSQ and MCQs both, then it would be more good. But still this thing is for the students who are going to attend the NEET exams in the coming years. So this is all for this question. Moving on to the next question. Before that, if anyone has any question, they can ask it here. Because we have this mole already given. Okay, we don't have to calculate mole for KCl. For that reason, we are not considering the formula. Okay, so we need the number of moles. And it is already given in B option. You can see it very clearly. It is 0.5 mole of KCl in 200 ml. Now moving on to the next question. One of the statements of Dalton's atomic theory is given by compounds are formed when atoms of different element combine in a fixed ratio. Now this is a very conceptual question which is related to two topics. First is your Dalton's law of atomic theory and second is your law of chemical combination. You have to decide that the given statement is not related to which of these four statements. Again, this is a multiple select one. So your time to solve this question starts now. I'm giving you some time to solve it. So again, remember, two answers can be correct. So I'm leaving this question to you. We will move to next question. Okay, so just try to analyze this and get the answer by yourself. Our next question is 45.4 liter of dinitrogen with 22.7 liter of dioxygen and 45.4 liter of nitrous oxide was formed. Then the reaction is also given. You have to say that which law is being obtained and write the statement of that law. So you can solve it. I will tell you the answer tomorrow. Yes, it is the difference between NTP and STP. Very good. So you have to say that which law is being followed here. So let's see how can we do this. This is your reaction where 2 moles of nitrogen is reacting with 1 mole of O2 to give 2 moles of N2O. In this you can see that the reacting ratio is what? According to the given equation, it is 2:1:2, which is 45.4:22.7:45.4. So this is a simple whole number ratio. Now, what is the law that decides this ratio? It is your Gay-Lussac's law of gaseous volume. Is it correct? If you have any issue, you can ask it. It's very simple. Our gaseous law is being Gay-Lussac's law of gaseous volume has been explained using this equation, and it is very true also, because 2 moles of this is reacting with 1 mole of this to give 2 moles of this, and in 1 mole of O2 at NTP we will have 22.7 liters, and in 2 moles of N2 we will have 45.4, because 2 multiplied by 22.7 will give you this. So it is 2:1:2. I have told you already. It is 2:1:2. Yeah. Now moving on to the next question. So I have tried to cover each and every concept that is related to this chapter, including the smaller ones also, like your laws of chemical combination. Now this next question is related to calculation of average atomic mass. You have the relative abundance given and you have the molar mass of each of this. Now, what was the formula to calculate this? Remember, you have to use the relative abundance and not the percentage relative abundance. Now, the work for you is to know how to calculate this into relative abundance. It's very easy. So, each time you are using the average atomic mass, you are using your atomic mass. I have told you already about this difference. And why do we take this thing? Now, how we'll solve it? So yes, it's very easy. Just divide this thing by 100 to get the relative abundance. So this will be a formula accordingly. Now what I have done in the calculation is that I have directly divided the whole thing by 100. You can divide it separately also. Here I have divided the whole thing by 100. So natural abundance of this H1 multiplied by the molar mass plus the natural abundance of the deuterium multiplied by the molar mass. And why I have divided this thing by 100? Again, I am making you remember, because you need to convert this natural abundance to from percentage to the fraction. Now just put all the values. It is really given in the question. So it's very simple to calculate it, Abhi. So what you have to do is, first thing you have to do is to make this percentage thing, convert it into fraction. To do this, you have to divide 99.985 by 100. Okay. Second thing, whatever the fraction you get, just multiply that thing by their molar mass. So I have done the same thing. This is your natural abundance multiplied by the 1. Divide by 100. Okay. Same thing will be done with the deuterium, that is the second isotope. Convert this thing into fraction by dividing it by 100. Okay. You have to divide it by 100, not multiply. So doing this and multiplying it with their molar mass, which is 2. Now if both have 100 in their denominator, I have taken the 100 common, and then you can simply do the calculation. So the formula is fraction natural abundance into molar mass and the summation of each of this isotope. Very simple. You can do the same calculation for each and every one. Got it? Yeah, you will only get the correct atomic mass when you will consider the protium. Okay, so that will give you 1.008. Very good. Moving on to the next one. So it's tritium, I guess, not protium, it's tritium. Same formula you have to apply. Okay, you don't have to worry. The same formula will be applied in that case also. So here is a match the following type question. You have to match each of this with the respective column 2. How we'll do this? So you must be clear with your conceptual ideas of mole concept, then it will be very easy. Yeah, you will have 3 terms in that case. This is your correct answer. 88 grams of CO2 will be related to 2 moles. B, 6.022 into 23 molecules of H2O is related to 1 mole of H2O. Then in option C, 5.6 liter of O2 is related to 0.62 mole, 0.2 mole of O2. 96 gram of O2 is related to 3 moles of O2, and lastly 1 mole of any gas is related to 6.022 into 10 to the power 23 molecules. Now, how do we calculate it? Let's see. We will deal with each of them one by one. First of all, the weight in gram of CO2 should be taken. Okay. Divided by the molecular weight. So 88 divided by 44. So in this way we can calculate the number of moles. Right. It's very easy to do so. Given weight by molar weight. That will give you 2 moles of CO2. So how do we get option C? Okay, we will see this. Already I have explained this thing, that how do we calculate the volume related to the number of moles, but I will make you understand this once again if you have the issue. Second was 1 mole of a substance. So this is very clear from start, that if I am saying that 6.022 into 10 to the power 23 molecules of H2O, it is very simple to say that we have 1 mole of that substance. So we can say B is related to 3. Got it? Now what about the next one? So for C, it is 5.6 liters of O2 at STP. We know it that at STP, we have 22.4 liter of any gas if we have taken 1 mole of that same gas. Now, anyone has any issue with this STP thing? How are we coming to this point that we have 22.4 liters? You can ask it now if you have any issue. So, if is it so, okay, let's see how we can get this 22.4 liter. I have explained it already. So, when we say STP, it means that we are taking standard temperature, pressure. What is this standard? So, at this standard, you take temperature as 273.15 Kelvin. So, this is just a case of standard temperature and pressure where you are fixing your temperature as well as the pressure. So, pressure will be 1 atm. So, these two things are already fixed. Got it? Now, at this condition, if you take 1 mole of gas, of any gas I am saying, any arbitrary gas, then our goal is to calculate that what is its volume. So, this is the main thing about this line. Yeah, it is same everywhere. Whenever you take the gas at STP, the condition should not be changed. Okay. Now, what we will do? We will use the formula PV is equals to nRT. So, it is PV is equals to nRT. So, volume will be nRT by P. Great. Number of moles is 1. What will be the value of R? So, here we take it as 0.0821 liter atm per mole per Kelvin. Why I am taking it in terms of liter atm? Because we have our pressure in atm and we will get our volume in liter, which is used commonly. Yeah, it is 0 degree. Okay, so that is for NTP, normal temperature and pressure, 0 degree. Okay. So if you take 1 here, multiplied by the 0.0821, multiplied with the temperature, which is 273.15, divided by the pressure, which is 1, you will get your value as 22.4 liter. Okay. So it's very clear now that 1 mole has a volume of 22.4 liter. If it's so, then what will be the number of mole in 5.6? So it will be simply 5.6 by 22.4. So I have just used the unitary method. So in 1 mole we have 22.4 liter. So in 1 liter I will have 1 by 22.4, and in 5.6 it will be 5.6 by 22.4. It will give you 0.25 mole. Okay. So I have written it as 0.2 mole. Our next question is, next is D, which is 96 gram of O2. Now again, given weight by molar weight. It will give you 3 mole. Very easy to calculate. Similar to this A. I will not explain this once again. Now what about the last option? 1 mole of any gas will have 6.022 into 10 to the power 23 molecules. Similar to the B option. So it's a very easy question to understand, but a very conceptual one to get the idea of mole. Till this point, anyone has any issue? They can ask. So yeah, it is Gay-Lussac's law. So I will move to the next question now. Our next question is, combustion of 16 gram of methane gives 18 gram of water, and the reason is given as, in the combustion of methane, water is one of the products. So this is a assertion reason type question. So is it true? Let's see how we can do it. So 25 degrees Celsius is the NTP condition, normal temperature and pressure. two things are being given here. First is 16 gram of oxygen gives 18 gram of water, and second is the reason in which it is given combustion of methane is produces water as the product. So A is false but R is true. Now to answer this question, you must know the combustion of methane. That what is the equation for combustion of methane? So if you just look at the combustion equation, it will give that 16 gram of 30 produces of methane combustion will give you 36 gram of water. How is it possible? So the balanced chemical equation for combustion of this methane is CH4 plus 2O2 gives us CO2 plus 2H2O. Now many of you would have a problem with this formula or with this equation, that how do you know that the combustion of your methane will give you carbon dioxide and water. So for this I have a very helpful statement. Remember this every time you see a combustion of any hydrocarbon. So whenever you see combustion of any hydrocarbon, you will always get carbon dioxide and water as the product. As simple as that. Just take hydrocarbon and oxygen on the left hand side and carbon dioxide and water at the right hand side. Then balance it. Now the idea of how to balance it, it will be made clear in the coming lecture. So we will have a lecture on this thing separately. It's very important. It is related to eudometry, some important topic in your JEE. I will cover that later. But for the time being, you should remember that combustion of any hydrocarbon in the presence of excess oxygen will always give you carbon dioxide and water. Yeah, in the partial combustion where you have a limitation of this oxygen, there can be formation of carbon monoxide as well. So that would be mentioned in the question if it is there. But in this case, it is combustion. Got it? Now coming back to the question. Question says that what is the amount of water that will be produced on this combustion of 16 gram of methane? According to this equation, I think it would be very clear that 1 mole of methane is producing 2 moles of water. Yeah, it gives partial combustion gives carbon monoxide and very little oxygen. According to this mole concept, we know that 1 mole has a mass of 16 gram and 2 mole will have a mass of 36 gram, as 1 mole has a mass of 18 gram. So 18 into 2, that will give you 36. So this equation clearly says that 16 gram of methane combustion will give you 36 gram and not 18 gram water. Is it clear to all of you? So from this we can say that the reason is correct because we are getting water, but assertion is not correct. So if you have a doubt, you can ask. Again, I am repeating it. So first thing is that whenever you see combustion of hydrocarbon, means burning of hydrocarbon and oxygen, you will always get carbon dioxide and water. So you already know the reactant and the product for the combustion of any hydrocarbon. Consider butane, ethane, methane, propane, any hydrocarbon. Then in the next part you balance it. So there is a way to balance it. I'm not telling it you now. You can just wait for a while. We will come back to this thing. But for the time being, say we have already balanced the equation. So this is your balanced equation. According to this balanced equation, we can see that 1 is the stoichiometric coefficient of methane and 2 is the stoichiometric coefficient of the water. It means 1 mole of methane is combusting to give you 2 moles of water. Got it? Now what is the mass related to 1 mole of methane? It is 16 gram. The mass related to 2 moles of water is 36 gram. Now you can also say that 16 gram of methane will combust to give 36 gram of water. But the assertion says that 16 gram of methane gives 18 gram of water. Therefore, this is an incorrect statement. What is the second one? That combustion of methane will give water. Yeah, it is right. It will give water. So therefore, A is false but R is true. You have an issue? Is it clear now? Okay. Let us move further. So this question says that calcium carbonate reacts with HCl to give calcium chloride, carbon dioxide and water. Now, what mass of calcium chloride will be formed if 250 ml of 0.76 molar HCl reacts with 1000 gram of calcium carbonate? Name the limiting reagent, calculate the number of moles of calcium chloride and formed in this reaction. Now a long question is there against you. What should we do? We will try to solve it one by one. Okay. So starting from the concept of stoichiometry and stoichiometric calculation, coming on to the limiting reagent. Everything will be there in this question. If you are able to understand this, you are good to go with that whole section. Okay, so this is example number 1.43. So let us start. So don't miss any detail that I am saying here, so that you can get it to understand it one time. If you have any issue, you can ask it once again. Starting from our given equation, let's see what we can do. So first we will analyze the equation and the given data. The given data says that we are taking 250 ml of 0.6 molar HCl. Okay. Then can we calculate the number of moles from it? The number of moles of HCl? Yeah, it can be calculated. How? We know that number of moles has a formula of given mass by molar mass. Okay. So this is the formula that we have. But we don't have the given mass, nor we have the molar mass. But we have the molarity. And the formula of molarity is number of moles by volume of the solution in liter. Okay. So if we multiply the molarity and the volume, we will get moles. Did you get this point? It's very easy. It is molarity into volume. You must have heard this formula, M into V. From there, we are simply calculating the number of moles. Yeah, we are converting this ml thing into liter because we need the molarity into liter. Okay, we need the molarity thing in liter. For the molarity thing, we need it in liter. For that reason, we are converting it into liter. Or else we will get the millimoles. Has anyone has an issue till this point? They can ask. Yeah, we shifted the formula of molarity to get the number of moles. As simple as that. For the case of HCl. So we don't have the given mass and yes, okay, we don't have the given mass of HCl, so we don't use that formula. So symbol of millimole is mmol. Okay, it is mmol. But here we are calculating the moles directly. Yeah, we use the molarity formula. Now moving on to the next step. So I have simply used the formula, Alok. So molarity formula is given as number of moles divided by volume. So what will be the number of moles? So I am considering it for the HCl. So it will be volume multiplied by molarity. You have the volume of that solution. You just have to convert it into liter multiplied by the molarity 0.76. So you can get it in 0.19. No, we don't take it in milliliter. We take it in liter because the molarity formula says that volume of solution should be in liter. So I have converted this milliliter into liter by dividing this thing by 1000. Here is your 1000. Now what is the mass of calcium carbonate? It is 1000 gram. It is given in the question. No, you can't take it in milliliter. Never. Then here we can use our direct formula, which is given mass by molar mass. It will give you 10 mole as the number of moles of calcium carbonate. So you have the moles of HCl and you have the moles of calcium carbonate. So first thing is done. Okay. What is the next thing? The next thing is to analyze this equation. According to this equation, listen carefully. According to this equation, 1 mole of calcium carbonate requires 2 moles of HCl. Isn't it? It is given in the equation very clearly that 1 mole of calcium carbonate requires 2 moles of hydrochloric acid. Now, what can we say further? We can say that 10 mole of calcium carbonate will require how many moles of HCl then? It will require 20 mole of HCl. Again, the toffee concept, very simple to understand. If 1 is costing 2, then 2 will cost 4. Similarly, if 1 is costing 2, 10 will cost 20. Is it clear? Anyone has an issue till now? Till this point? So, do we have 20 moles of HCl? No, we have only 0.19 mole of HCl. So, it is that substance which is present in lesser amount, or we can say that HCl is the limiting reagent here. Okay, is it clear? So, we have constructed our first answer that HCl is the limiting reagent. Because we need 20 mole of HCl according to the given mole of calcium carbonate, but we have only 0.19 mole of HCl. Now the second thing is to calculate the number of moles of calcium chloride. Now again, coming back to the equation, we can say that, so this thing is written here. So if 0.19 mole of HCl is present, that means HCl is the limiting reagent. Now second thing is to calculate the calcium chloride mass, or the amount of calcium chloride. So we have to calculate the number of moles, not the mass. Again, coming back to the equation, since HCl is the limiting reagent, it will decide the number of calcium chloride that is being formed. So this thing is very important to understand. Okay. So since we have only 0.19 mole of HCl, that means it is the only thing that will decide your CaCl2 number of moles. Is there any issue in this point? How HCl is deciding the number of moles? So again I am repeating it. Since this HCl is not present in the required amount, which is 20 mole according to the given equation, and it is present in the less amount, so this will be the deciding one. Okay, because for further reaction we don't have HCl. The moles of, once the mole of HCl is consumed, you will not proceed further with your equation. Okay, so for that reason it will decide the number of moles of HCl. Now according to this equation, 2 moles of HCl will form 1 mole of CaCl2. Then 0.19 mole will form how much moles of HCl? It will be 0.19 by 2, or 0.19 into 1 by 2. That will give you 0.095 mole of CaCl2. So it's very easy to understand here that if 2 mole is giving 1 mole of CaCl2, therefore 1 mole will give half mole of CaCl2, or 0.19 will give 0.19 into half mole of CaCl2, which is 0.095 moles of CaCl2. Got it? So Sachin, remember that if 2 moles of HCl are reacting, then we are getting 1 mole of the CaCl2. So whatever amount we have of HCl, half of that will be formed for the calcium chloride. So it's very easy to understand it from here, that if 4 chocolates cost 2 rupees, okay, then 1 chocolate will cost 2 by 4, and 3 chocolates will cost 2 by 4 into 3. As simple as that. So that will give you your final answer as 0.095 moles of calcium chloride. Now we can calculate the mass also of the CaCl2, which was our last question. It will be again given mass into molar mass, which is 10.54 gram. So this was all about this question. So if you have any issue with this question, you can ask now at any point if you don't understand. So just go through this calculation once again. If you have any issue, you will get it. Yes, it will be simply 0.19 by 2. So you have to, I will suggest you that if you are unaware about this unitary method, just go and try to understand this. I will try to make you understand if I have any time. Instead, I will try to dedicate a lecture to this unitary method as well. Okay, half of any lecture, so that you can get to understand with this mole concept. So anyone has any issue till now, they can ask. So why are we writing? Why we are writing the mass of chlorine as 35.5, but we are not writing other elements as decimal form? Okay, so this is a very good question to ask. So why I'm taking it at 35.5? Okay, so whenever we try to round off something, okay, suppose something is 2.3, then we will approximately round it to 2. Very good. If it's something is 2.6, we round it to 3. But since this is in middle, we take it as it is. So you can think it of a reason. It would be a silly reason to think of, but this can be the only reason. Okay. So why are we multiplying, sir? So which multiplication you are asking about, Abhi? Okay. So yeah, it's so one part of a question is saying to calculate the mass of CaCl2. So number of moles is simply given mass by molar mass. So the mass can be calculated by the given mass can be calculated by molar mass into number of moles. So molar mass is 111 and number of moles is 0.095. For that reason, we are multiplying. Is it clear now? Okay. So this was all for the chemistry lecture today.